If you've been working with C# for a while, you know that there's a handful of different ways that we can initialize collections, and more recently, we've been given even more options to do so. Now, recently I saw a post on LinkedIn from Dave Callan that made me think, wait, how the heck is it possible there can be that big of a difference between just instantiating collections just because the syntax looks a little different? Hi, I'm Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In this video, we're going to be going over benchmarks for collection initializers, and I know that might not sound so interesting, but when you see the performance differences between these different ways that you can instantiate collections, you might change your mind. Now, as always, the goal with these types of videos is not to tell you that you have to go change how you're coding, it's really to show you that you can go benchmark things to go learn about them. Now, before I jump over to this claim about this performance, just a quick reminder to check that pinned comment for a link to my newsletter and my courses on Dome Train. With that said, let's go check this out. Alright, so I've created a blog article about this because I also wanted to document this in written form, and the original post from Dave Callan has these two examples here where he has this baseline for regular lists where he's just creating this benchmark that makes apple, banana, and orange 3 elements inside of a list using this traditional collection initializer. Now, when we look at the collection expression for a list, we see apple, banana, and orange, the same 3 exact elements. It's returning a list here, and the only difference is that we're using the syntax that has square braces. That's it, right? Like, we don't use the new list string with curly braces, it's just the square brackets. Both of these things go make a list of strings with the same 3 items in it. Now, here's the catch. If I scroll up a little bit, here's the benchmark result that he posted. And Dave is awesome for posting really interesting benchmarks. I love looking at his content because every time I'm looking and I'm like, man, I really didn't expect to see that. There's always something really cool. And in this case, if we look at the ratio column, right, the regular list being the baseline, his claim from his benchmarks was that the collection expression list was 1.58 times faster. Like, that's a dramatic improvement. I know we're talking about really small lists here. I know that this could be maybe outside of context for many of your applications. This is why I said I'm not trying to tell you to do it a different way, but this is really interesting to see. And that got me curious because I said, look, I'm going to go try to benchmark a whole bunch of these and see what the difference is. So I'm going to jump over to Visual Studio now. We'll go through some of the benchmark code so you can see how it's set up. We'll look at the lists in particular so we can see similar results or not to what Dave has here, and then we'll talk about those. And again, the point is I want you to see how the benchmarks are set up and just remind you, you can go do this on your own code and try and prove out different things. I'm encouraging you to do that. I'm not going to walk through this setup for BenchmarkDotNet. I'm just going to point out that's what I'm using, and we have the benchmark runner at the top. And then I'm going to go through the list benchmarks that we have here. So the few things that I want to point out, these are going to be reused in a few different benchmarks. So this is just going to be the same set of 3 elements, just like Dave had in his example. And I have a couple of different variations that aren't the same as what Dave had, but ultimately they're list variations, right? So I'm starting with a classic collection initializer. This is exactly what Dave had. I just put it on different lines, right? Like nothing different there. But then I have a variation of that where we explicitly set the capacity, right? So there's 3 elements here. I'm going to set it to 3. In this particular case above, we don't set the capacity at all. I don't think there should be a difference in that, but why not try it, right? Like, I'm curious now that Dave's posted this. I didn't think those 2 things would be different anyway. Scrolling a little lower, we have the collection expression. So this is again the second example that Dave had. That's the one that's supposed to go really fast in comparison. And then I wanted to try out a few variations that aren't the exact same thing, right? Like in this case, we are starting with 3 explicit items. I wanted to say, hey, look, if we went and copied that data that we had and we were copying it from an array, could we go make a list, and what would the performance characteristics of that be like? Especially if we compare it to the initial case or the baseline case that we had. What does it look like? And the same thing, very similar, right? If instead of copying from an array, do we have different characteristics if we're using an iterator? And I would expect that this should be slower because just by creating and using an iterator, it should be slower. There's overhead for doing that, especially with only 3 items, right? So if I scroll back up, you can see the iterator here. Like, it's an enumerable, but it is truly an iterator because it's yield returning those things back. So go back down. Those are the two copy constructors that we have. And then I was like, look, Dave's example, it blew my mind, right? Those two things should be the exact same. So I wanted to say, hey, look, if we go make a list using that same syntax, but not putting the items in it in the first place, if we go manually add them, what's the performance of that like? And similarly, if we go do it with new and we put in the capacity, what's that going to look like? I can't put a capacity up here, so if I try to put 3, it doesn't allow it. You can see that it's put the squiggly line here, so I can't do an exact comparison, but when I new it up, I can provide the capacity. So I did do that and then add those 3 things manually. So a few different flavors we're looking at. We have the 2 that Dave was calling out. I've added a variation of that with capacity included. Then I did 2 copy constructor variations, and then I did these 2 variations where we're manually adding stuff, because why not? We're already here. We might as well run the benchmarks. Okay, now you've seen the setup for it. This is the part where I go run this video for another 25 minutes. You can hang around here, wait for these benchmarks to finish. I'm going to go check the food in the oven, and I'll be right back while you hang out here. Let's go ahead and check out the numbers. So the important column that we want to focus on is this ratio column. Mine is a little bit different than Dave's. Mine doesn't say the percentage faster, but it says the fraction of the time that it took, right? So a higher number in the ratio column is worse. It means that it took longer to run, but we are interested in this middle column here that says ratio. The very top, we have the default case, so no capacity being set, but we provide 3 items. This is the first example that Dave had. And if we look at that, that's a ratio of 1. That's our baseline. The first version of this that we run, just by setting a capacity of 3, is almost half the time. And really, that's the punchline of this whole video, right? Like this one, just by setting the capacity, you're almost doubling the performance. This is faster than all of the other variations that we have here, but I still want you to stick around so we can talk through this and make more sense of it. Because if you leave now, you won't see if Dave was right or wrong, right? And that's what you really want to see. So if we look next, we can see the collection expression. This is the one that Dave also included, so maybe I shouldn't have put these one after the other, but still hang around. We can see that we have a 0.64 ratio. This is going to be basically right on par with what Dave had. If we invert it to get the speed multiplier, so 1.562, what did Dave have in his example? If I scroll back up through my blog, sorry for your eyes, he had 1.58, almost the exact same number, right? So Dave was spot on. You can go way faster than just the normal collection initializer by using the square brackets. But you can also use the traditional one and just put the capacity in too. That's going to be even faster, apparently. Now, copy constructors, they're slower. We can see these 2 in a row, they're slower. I figured that was probably going to be the case. But here's what I thought might be interesting to consider. I knew that the iterator one was going to be slower. I didn't know how much slower, but I knew it was going to be slower because iterators can suck when you have a small amount of data and you need to be able to set up the iterator in the first place. So slower, not surprised. The copy constructor using an array as a data source, to me, is a little bit interesting. I would have thought that it being a concrete collection where we know the count, that there might be an optimization behind the scenes that sets the capacity and therefore makes adding items in pretty fast. So I would have expected it to be maybe a little slower because it's going to iterate over it, but I also thought that maybe there was some type of array optimization behind the scenes. I didn't want to go spoil it for myself and check it out. I just wanted to run the benchmark and see. So I am quite surprised that it's almost twice as slow. Not quite, but it's slower for sure than the baseline. Now these next 2 results are interesting. I'm pretty shocked. The manually adding of items into a collection, right? So if we use this no capacity one, it did use the new format with the square brackets. It's slower, right? We're manually adding stuff, no capacity set, and I'm not really surprised that it's slower. It's about 10% slower, right? We have a 1.1 ratio here. So, okay, I'm not shocked by that, but look at this next line. This is manually adding things in, right? We are adding the 3 items one by one. We did set a capacity though, and it's half the time, almost half the time, right? It's a little bit over of the counterpart right above it. That means that manually adding 3 things is actually faster than a traditional collection initializer without a capacity. In fact, according to these benchmarks, it's even faster than the example that Dave gave. These two numbers, 0.61 and 0.64, are extremely close. I would say, like, if I ran these again, they might fluctuate and maybe they're right on par with each other. But the interesting part is, in this particular case, it came out to be a little bit faster, right? Regardless, the fact that it's on par with it is shocking to me. I would not have expected that by manually adding 3 things after, even with the capacity set, would be faster. To me, that's just shocking. So if we look through the 3 fastest ways that we have here, it is a classic collection initializer with setting a capacity. That is kind of weird to me, and I want to call that out because I'm not sure at compile time why this would be complicated to do, but I would figure that if we listed out a few things and it was constants, right? If we had a constant set of things being added, we should know what that capacity is. So I would think that maybe there's some type of compiler optimization where we could go inject that number as the capacity. I don't work on the .NET team. I'm sure .NET people that work on the team know why that can't be done, or there's some other reason for it. I'm sure someone's thought of it, but I don't know the answer, so to me it's a little bit surprising. That is the fastest way in this list. I'm not saying there aren't faster ways. The next one that we have is one of the last ones we looked at, and that was declaring the list. So classic list declaration, setting the capacity, and then manually adding in the 3 items. That was literally the next fastest way that we had. And the third fastest way is what Dave showed in his example that got me to put this together in the first place. I still find it completely fascinating that just declaring it with a different syntax, right, using square brackets instead of curly braces, 0.64 compared to 1, it's pretty dramatic. And look, I need to say it again because I'm sure someone watching this or someone will get into the comments saying, well, this is completely contrived. Like, who cares about these little optimizations like this? You shouldn't be wasting your time trying to micro optimize like this. Like, I get it. That's not my point, right? I thought this was interesting data. I wanted to go explore and try it out. Like I said in the beginning of this video, the whole point is not to tell you, you better go switch all your code to square braces instead of curly braces. The point of the video was to say, look, if you're curious, you have all of the tools at your disposal to be able to go measure this stuff. In fact, that's exactly what I recommend you do if you're trying to get more speed out of what you're building, right? Profile your code and benchmark it with the alternatives. And if you want to understand how to do that better, you can watch this video next. Thanks, and I'll see you next time.